Hello, boys and girls and parents. I hope everyone has had a marvelous Monday, ready for a Monday math video. Okay, boys and girls, we're looking at multiplying with decimals. And with that, we are also looking at the estimates. So in this first problem here, we want 28 and 9/10 copies of 5, okay? If you flip it around, we could say we want 5 copies of 28 and 9/10. It's going to give us the same product. Okay, but they both mean something different. Okay, so in this first one here, if we round this up, we would round it up to 30 times 5. We're going to keep 5 because it's a single digit, and we would get 150. And if we round it down, it would round to 20 times 5. Hopefully you're telling me 100. So I know my product has to fall between those two numbers, 100 and 150. Now, if you look up here, 28 and 9/10 is definitely closer to 30, so it's got to be closer to that 150 without going over, okay? Okay, we're going to use that area model. Okay, so look over here. We have, what do we have? We have 28 and 9/10, so I'm going to decompose it to 20 and 8, and then this is 9/10, and then up top we're going to have 5. Okay, so we're definitely not using that column, and we're not using that column. So here we would have 20 times 5, which would give us 100, and then here we have 8 times 5, which would give us 40. And then down here we have, look at this, 9/10 of 5. You want a fraction of 5. Or think about it like this, 5 copies of 9/10. 9/10, 9/10, 9/10, 9/10, and 9/10 would give you 45 tenths. And if you think about 45 tenths, it's over whole. So we've made 4 whole with 5 tenths left over. Remember how we talked about 45 tenths is you only have one digit after, the others would have to go in front of it, 4 and 5 tenths. Okay, we've got to go over here now and add them all up. So we have 100 decimals at the end. We have 40 decimals at the end. I'm lining them up. And then I have 4 and 5 tenths. Okay, we can add placeholders. We've got a 5 there. Bring your decimal down. You've got a 4 and a 4 and a 1. Final answer, 144 and 5 tenths. Okay, we could even check it on our calculator. Let's see, we have 28 and 9/10, and we're going to multiply by 5. Oh, look at that, we're right. Okay, boys and girls, we are moving on to the next multiplication problem. Okay, high and low. So the high, if we round both of these up, that would round up to 7, and this would round up to that 6. So the high would be 7 times 6, which gives you 42. Now my low would be dropped down to the 6 times 5. Gives you 30. What do you guys think? Closer to 42 or 30? Look at those numbers. Is this closer to 7 or is it closer to 6? This is definitely closer to 7. What about this one? It's closer to 6. So I'm pretty sure it's going to be closer to that 42 whole. Okay? Okay, we're going to go over here. Now remember, when we're multiplying with decimals, we don't have to line them up. Now if they line up just because they line up the way we write them, that's okay. So like in this problem here, they do line up, but we don't have to have them lined up. Okay, we're going to multiply everything by the 8. Okay, 8 times 7, 8 groups of 7. 56, regroup that 5. 8 times 6. Now decompose it if you need to. I know that if I break that 6 apart into 3 and 3, I can do 8 times 3 and 8 times 3. Both give me 24. So if I put them back together, I have 48. Okay, 48 plus 5 more. I'm thinking in my head, I'm going to take 2 from the 5 to make that 48 of 50. And then I have 3 left over, 53. Okay, cancel, cancel, just like a normal multiplication problem. One placeholder because you're on the next digit. Now we have 5 times 7, 35. Regroup that 3. 5 times 6, 30 plus 3 more, 33. Okay, draw your line because we only have the 2 numbers there. And you end up with a 6, an 8, another 8, and then a 3. But we're not done. Go back up here. You've got 1, 2 numbers behind the decimal. So we've got to go down here and go over 2. 1, 2. So my answer is 38 and 86 hundredths. 38, 86 over 100. All right. And if you think about it, it is between 42 whole and 30 whole. And it is definitely closer to the 42. Okay, you guys want to check in on this? Let's see. Let me clear that out. Look at that. You guys see it? We're right. And we've got all the work to back it up. You got to have that work to back it up. Okay. Okay, take a look at the next one. We are looking at a subtraction problem, okay, with fractions. We got 6 1/4 minus 5 3/6. Okay, now think about our benchmarks. We've been using that half a lot. Okay, so this right here, that's less than half. That's a half. That's exactly a half, isn't it? Okay, remember how sometimes I'll grab these little pieces here? If you got 6 of them and you give me 3, you're giving me half of them. If you've got 4 and you only get 1, you're definitely not getting half. Okay, so if I need to take half away from this, can I do it? I can't. There's not enough over here. So I know I'm going to be regrouping, which means that's going to turn to a 5. And 5 minus 5 is 0. So I'm not going to have a hole in this problem. Okay, bring down 1/4 and bring down 3/6. Now remember, we can just take 4 and 6 and multiply them together and get 24. Or we could do down here and find the first one. Some of you guys are working on 6th grade levels and you are working on this. So 12 is the first one they have in common. Okay, but like I said, if you did 24, I would give you credit for it because you can just multiply those. Okay, so 12 there, multiply the top by 3, you get 3/12. Down here, multiply the top by 2, and you get 6/12. And yeah, that is a half. Okay, bring everything down. I got 6 whole and 3/12. And I'm going to subtract from it 5 whole and 6/12. Okay, like we said earlier, we can't subtract this. We don't have enough over there. So we're going to regroup. Remember, go off to the side to regroup that chunky 1. Now my denominator's not 10, so don't put a 10 over there. My denominator's 12, which means that chunky 1 is 12/12. So I'm going to add 12 pieces to the 3, which gives me a total of 15 pieces. Now I can subtract 15 minus 6. Hopefully you're telling me 9 12s. And then 5 minus 5 is 0. Okay, boys and girls, we are ready to move on to the next problem. Okay, right here. Now, in this problem here, we want over 82 copies of that. So I know it's going to be a bigger number, right? I want you guys to think about what this means. That's 10 to the 4th power, isn't it? We're going to move all those digits to the left 4 spots. So right now, I'm going to put my decimal right there. Right now, I've got 2 spots in front of the decimal. I'm going to have to add 4 more. 1, 2, 3, 4, which means that 8's going to go there, followed by the 2, the 5, the 4, and then I need 2 placeholders. 1, 2, 3, comma. We have 825,400. I hope everybody's got that. Think about this. That's 2. That value is 2. 2 groups of 10,000. That'd give you 20,000. Look where the 2's at. That's 20,000. It's in the 10,000 spot. Okay, here we want a fraction of it, a piece of it, a part of it. We don't want all of it, okay? It's like we're sharing it with 10 people. Now, right now, there's no decimal. We know where it is, though. It's at the end, okay? Now, all of those digits are going to go back one spot, which means that 5 is going to go back one spot. That 2 is going to go back one spot. The 8 and the 7. Okay, days and hours. There are definitely not enough hours in a day. Have you guys ever heard that? I say it all the time. But there are 24 hours in a day. So I want 8 groups of 24. What if we did 8 groups of 20 and 8 groups of 4? We decomposed it. 160. And this would give me 32. If I put them back together, I have 192 hours. Now, if I just did a regular multiplication problem to regroup the 3, 16, 17, 18, 19, I get the same answer. Same product. We got to speak math. Okay, over here, 1 meter. Think about that meter stick in my room. And so, for example, this breaks open to that meter stick. Now, remember, my millis are the teeny tiny ones between the centimeters. And there's 10 of them in each centimeter. And there's 100 centimeters on a meter stick, so that would be 1,000. 1,000. Okay, cups and ounces. When you drink 1 cup of milk, you are drinking 8 ounces. Now, some of you guys are thinking about pounds. 1 pound is 16 ounces, but 1 cup is 8. Okay, we have 2 more to go. Expanded form. We've got the 7. 7 times 10 to the 5th power, because if you think about it, it's got 1, 2, 3, 4, 5 after it before the decimal, plus 3 times 10 to the 4th power, plus 1 times 10 to the 3rd power, plus 3 times 10 to the 2nd power, this is look 2 after it, plus 4 times 1, plus 4 times decimal 001, or 1 over 1,000. Could do it both ways. Okay, don't forget this one. I'll say it for you. 731,000. Don't forget the comma. 304 and 4 thousandths. Don't forget to write it. Okay, here we go. This one here, if you have a number and you're adding to it, you get that big number. So would this number be something bigger than that? Definitely not. It's going to be less than that because we're adding something to that to get that. So we are looking at a subtraction problem. And remember, we've got to line up our decimals. I'm on my placeholder right now. 4 in the ones underneath the 5. The 3 is in the tens, and then the 9 is in the hundreds. Okay, got a 9. Can't do that. Regroup from the ones. So if you think about maybe this being a 1, if you regroup and turn them into the tenths, you'd have 10 of those little things. So that's why I'm putting a 10 there. 10 tenths minus 3 tenths gives you 7 tenths. 4 ones minus 4 ones gives you 0 ones. 30, because that's the value of it, minus 30 gives you 0 in the tens. 200 minus 900. Can't do that. Regroup from the 1,000, so I'm regrouping 1,000, which is 10 hundredths. That's why you're putting a 10 next to that 2. So you have 12. 1,200 minus 900 gives you, hopefully you're telling me 300. Now, last week in the video, I said add up. Okay, even though it's a subtraction problem, sometimes it's better, or it's not necessarily better, maybe it's easier to add up. This is what I meant in it, because I know I had some of you guys confused. So I'm finding the difference between these numbers. So adding up means, what did you need to add to the 9 to get to the 12? Okay, I know if I added 1 more, I'd get to the 10. And then from 10 to 12, I'm going to add 2 more. So I have a difference of 3. That's what I meant last week when I said add up. Okay? So even though it's a subtraction problem, you could do the adding up. I know Mr. Simmons says that he loves adding up when he subtracts. Okay, boys and girls, I hope the video has helped you. We did it in less than 15 minutes, and that was a lot of extra little explaining. Okay, oh, here's a good one. If you could redesign your home, what would it look like? Okay, so kind of like if you were to give your home a makeover, a home makeover. What would you do to your house? How would you make it over? If you could maybe start over and build it completely from scratch, or maybe you're just going to redo some rooms, what would you do at your house? Boys and girls, as always, if you have any questions over any of this, you can message me tonight, or you can ask me in class tomorrow or in the hallway when you guys come in. I want to make sure everybody truly understands this math, and I will see you in the morning. Hey, guess what? We only have 4 more school days until we have that break. You guys can do it.